Okay, in this video, we're going to talk about the periodic table and help you with the assignment periodic table guided notes. So the first thing we need to understand is when we have one element. At the beginning of this lesson, if you missed it, we had a balloon that was filled with hydrogen gas. So let's see if I can kind of draw a balloon here. And hydrogen gas is a very lightweight gas, and so it floats, and we had it attached to a stool. And then we talked about the different properties that we knew about hydrogen gas, and eventually got to where we explained that hydrogen gas is flammable. Add a little bit of a flame here, okay? And when we introduced a flame to the gas, then it very quickly exploded. Okay, big ball of flame. Okay, then we talked about helium gas. Now, if you remember, helium gas also is flammable. Let's see if I can move. No, I can't. Helium gas is also flammable. Helium gas is not flammable, but also floats in a balloon. And so I asked the question, what makes hydrogen, represented as an H, and helium, as He, different from one another? The answer is simple. Hydrogen is an atom. In its nucleus contains one proton, and sometimes has an electron floating around it. Helium, however, in its nucleus contains two protons. That is solely the difference between one atom and another, is the number of protons that it contains. Okay, now helium also will have neutrons, and it'll have two electrons. Okay, but it's the protons that make it different from hydrogen. Okay. So in essence, we could take something like oxygen, which has 8 protons, 2, 3, 4, 6, 7, and 8, and we can make hydrogen into gold, hypothetically speaking, if we combined hydrogen with, and so gold has 79 protons, so if we were able to combine hydrogen with an element that has 71 protons, we would thereby make gold, okay, which is element Lu, and I'll be honest, I don't know the name of Lu. I could do a quick Google search, but it has 71 protons. Gold has 8. 71 plus 8 makes 79, which is gold, or Au. Okay, but that's the difference between them. It's just the number of protons. Okay, now for this next bit, it should help answer both what does the atomic number represent, what does atomic mass represent, why isn't the atomic symbol always an abbreviation to the name, and help you label the different parts of that tile, okay, that's on slide 2 of this assignment. Okay, so we have this carbon, okay, that's a 6.011, okay, and of these different things, we've got the symbol, okay, here in red, circled in red. We have the name that I told you to circle in blue. Okay, the atomic number was meant to be done in green. Okay, and then the atomic mass in orange. Okay, like that. So that's what that slide should look like. Now these different things all represent something else about that atom. So this number, called the atomic number, in fact, let me erase this really quick, and I'm going to write with a thinner pencil stroke. So atomic number, hashtag means number, it represents the number of protons. Okay, we talked about oxygen and gold being different simply from the number of protons. Well, that's the atomic number. Okay, this number over here is the atomic mass, and it's represented by the total mass of the atom. Now, if you remember from our lesson about subatomic particles, we learned that the mass all comes from the protons and neutrons. So this is the number of protons plus the number of neutrons. Okay. Here, this is the symbol, and then this is the atomic name. Okay. Now, the symbol, the reason that the symbol is not always an abbreviation of the name is quite easy to understand. Now, we just saw that carbon is C, which is an abbreviation of carbon, but you have other things like lead is PB. Now, these symbols, like PB, are actually abbreviations of the Latin name, which for lead is plumbum. Okay, so PB for plumbum. Okay, so that's, and when those don't line up, that explains why. Okay, the last thing I wanted you to have in your assignment for this activity is I wanted you to have written down and heard explanations for the 9 elements that I wanted you to memorize. So our first was H, which was hydrogen. Okay, we're going to remember hydrogen because it is flammable, it's lightweight, it's the smallest element. Next is He for helium. Okay, we're familiar with helium. It's an abbreviation. He is an abbreviation of helium. But another thing you can think of is He. When you breathe in helium, you begin to giggle, and when you giggle, what are you saying? You're going heat. You get it. Okay, so then we have helium. C is carbon. Now, one thing I always think about with carbon is the building blocks of all living things. Okay, if you've ever played with Legos, you know that the best Lego is Lego that's a 2x4. Okay, the reason that's the best Lego, it's the most stable. You can make the most connections with it. You can do the most with it. Well, that's like carbon. Other things like oxygen, that's more like a 1x2. There's not a whole lot I can do with that. Okay, and so oxygen is one that wouldn't be used as the backbone for many molecules, where carbon is the backbone of all living things here on Earth. Okay, our next one is N, which is nitrogen. Nitrogen is the most plentiful atom in our air. It consists of 70% of the air that we breathe. Also a fun story about nitrogen that I remember hearing. Back in World War II, there was a scientist who was trying to pull nitrogen out of the air to create trinitrotoluene, or TNT. Now, so he's trying to create a way to make a bomb out of this nitrogen in the air, and he was never able to succeed. However, he did succeed in creating nitrogen-based fertilizers. So I enjoy this story because it's quite ironic. He was creating something to kill thousands, but instead created something that we use to help feed millions. Okay. Next one on our list is O, which is oxygen. Okay, very important. Can't live with it. It's also killing us at the same time. It's quite reactive, but very important to our survival. Then, zoom back in here, we have Na, which is sodium. Okay, this is our first one where the symbol is not an abbreviation of the name. Okay, for this one thing that can help you is you're going to think of Batman. Okay, why Batman, you might ask? Well, do you remember the old Batman theme song? The old theme song was na 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 sodium, sodium. Na 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 sodium. You get it. Okay. Next, we've got P. Now, P is one that the chemistry teacher at the high school specifically wanted you guys to know. It's phosphorus. Okay. Phosphorus is used on the top of a match. So if you have a match, that top part up here, that's phosphorus. It's very reactive, just takes a little bit of friction, creates a fire, and it's when you draw that match, it looks like a P. So we can think match, P, phosphorus. That's what we could be thinking here. Okay. Next we have Cl. Cl is chlorine. Now, where's an area where you smell a lot of chlorine? Well, at the pool. We often smell chlorine at the pool. Okay, what else is at the pool? Well, at the pool we have our cute lifeguard. Cl, cute lifeguard, chlorine. Okay. And then the last one is K. K is for potassium. Okay. fact, I think there's 2 S's in potassium. Hold on just a second. Yeah, 2 S's in potassium. I actually really butchered that spelling. Oops, why am I on a highlighter? Potassium. Okay, now a good source of potassium are bananas. So we're going to draw a banana. Our first banana is there on its back. Second banana laying next to it. Those together make a K. And those are the elements that I want you to have memorized. Hope this helped you get that assignment finished, and then you can get it turned in.